हाँ ये बस नहीं है बस आई विषय ही बस नहीं है
जोर से उठा ले
कौन है क्या करना है चल चल
कोई तो उधर जाओ
मयंक की
मेरे को दे दे कोई आपको आयुष आ जाए
ये आजा तू चल
मेरे को दे
जल्दी मेरे को
यार कौन है
हो गया
इसको छोड़ देना भाई वापस आ हाँ ना गाँव से करे हमने वापस जाओ पुणे में जाओ किधर
ओ भाई आते बात है इसकी तो ओए गया
कौन है
माइक है बाइक हेडशॉट
इन्हीं को एक पास ही आया
that's what I think just around my
नाइस
मालूम नहीं साला बहुत गंदी तरीके
ये मारो बावड़े
वही कट आया
ओ भाई नाम को भी दे दो
क्या पागल है
वो ऐसे दे सकते हैं
ये क्या अलग है
चांस
सॉरी
आराम
ठीक है ना
ओ भाई
ये बात है
टॉमी
मेरे को अरे ओ भाई ओ अरे लेने तो
अरे मैम को बोलने की होगी
नहीं रे
मेरे को
अभी गई होगी तो गया
अरे मैम है तो तुरंत बैठ के
सम आज अच्छे कंप्लीट कर गई
कंप्लेंट करने गई तो बॉल छुपा दो हां वही बॉल फेंक देंगे
ये बॉल उसी के बैकवर्ड
बॉल गाड़ी के बैग में
मस्त सीसीटीवी दिख रहा
हां बॉल गाड़ी के
एक हमको नहीं हम लोग
बॉल गाड़ी के
सारे जल्दी
हम बोल रहे हैं
ये मत डाल रे
एक गाड़ी हम लोग गाड़ी में डाल रहा है ऊपर है के लिए
गाड़ी में कमरे रहेगा वो संस्कृत है चला वो कर दी बहुत
कंप्लीट है
ठीक है ठीक क्या जो क्या बोलते हैं वो खेलते हैं
चिड़िया चिड़िया
चिड़िया आया चिड़िया भी खेलते हैं आपका यही करते हैं
चिड़िया माने
चिड़िया उड़ी वॉशिंग मशीन मोड आउट
चिड़िया
चिड़िया
तोता मेंढक उड़ चिड़िया
ए फिजिक्स केमिस्ट्री का किसको लेक्चर चाहिए फिजिक्स केमिस्ट्री
हम लोग को चाहिए ना मैम
हाँ मैम चाहिए
मतलब एक फिजिक्स
अरे
का
हमने बोला
मैम हम लोग के
कैसे
फिजिक्स का एक लेक्चर होगा
किसी बोला से
फिजिक्स का नहीं चाहिए केमिस्ट्री का
केमिस्ट्री है मंडे
फिजिक्स का नहीं हुआ केमिस्ट्री
केमिस्ट्री का हुआ केमिस्ट्री का
केमिस्ट्री का फिजिक्स
chemistry same.
मजा आता है छोटी छोटी
ये मैं जाऊंगा अंदर we have something
different forms of
वो तेरे बैग में ही है नहीं किया different forms of
So quickly tell me what are the different forms of energy? How many forms I've told you? There are seven.
So
what are they?
Mechanical.
First, we'll start from the most primitive form, okay? We'll start from the most primitive form. What is it? So light, okay? Light, sound. These are the most primitive form, right? Even so, then we had heat when man discovered fire. Then chemical burning, right? So chemical. After that, solar is light. Nuclear is last. Electricity. That is electricity, right? Electricity. Heat, light, sound, chemical, electricity. Is it seven?
nuclear
What are you missing?
Mechanical. हो गया
Mechanical is somewhere.
Yes sir, मैंने बोला
यहाँ पे है. ठीक है? So these are total how many types?
7.
1, 2, 3, 4, 5, 6, 7. In this chapter, we will learn only about mechanical energy. And about rest of the energy, we will see how one form of energy can be converted into other. Right? So what are we going to study in this chapter? So here we are going to study about mechanical energy. What is mechanical energy? So what of these different 7 types of energy we will study about mechanical energy. What is mechanical energy? It is the energy possessed by the body by virtue of its state of motion or change of position or configuration. Right? So there are basically 2 types of energy. Kinetic energy mechanical मतलब motion, okay, and potential energy. What is the symbol of kinetic energy? K. Symbol of potential energy is capital U. Okay, so when we say mechanical energy, see silence. Pay attention here. When we say mechanical energy is E, so total mechanical energy is sum of kinetic energy plus potential energy. Understood? So what is the total mechanical energy of any body? It is the sum of its kinetic energy and potential energy. So now let us understand what is kinetic energy. Is the energy possessed by the body by virtue of its state of motion. Okay. So what do you understand with this? Any moving body has an energy.
Yes.
That energy is kinetic. Kinetic means motion, moving body. That's why bullet has energy. Or a cricket ball, which is, which is moving very fast, has energy. Because if you try to, like, it's coming towards your nose, and you miss it, what will happen? Ball will do work on you. It will hit it. Okay? So when it hits you, what will happen? Energy, whenever any body possessing energy interacts with any other body, it will work on that body. Meaning it will exert force and it will cause displacement. Got it? So, if you experience sudden, impact, you will lose your nose. Why you lost your nose? Because of the kinetic energy of the body. Okay? That's why bullet hurts. It can kill you also. Right? So, what is this kinetic energy given as? Half mv square. Any body whose mass is m and who has speed v, its kinetic energy is given as half mv square. Somebody is just speaking parallelly, which means he is not listening to what I am saying, which means he will not understand. Pay attention. What is this kinetic energy equal to? Mass times square of velocity divided by 2. So how do we get this? So derivation of, let's derive it. Derivation of K is equal to half mv square. How will you derive it? कैसे derive करोगे इसको बताओ? I told you energy is same as work. Whatever work I am doing to stop a moving body, it must be equal to the kinetic energy in the body. Correct? Because work and energy is same. So, since kinetic energy of a body is equal to what? Work done in stopping a moving body. Okay? This is how I will get expression for kinetic. So consider a body of mass m. Okay, let us say it was moving with velocity v. It is moving with velocity v. Now a force is applied in opposite direction to stop it. So let us say this body stops after traveling distance s. Here the body stops. Right? So what is the initial speed? U is equal to v. Initial is u is v and final velocity is 0 when it is finally stopped. What kind of force is this? What kind of force is applied for the body to stop? Retarding force. So when a force is applied, it is experiencing force is in this direction and displacement is in this direction. So what is the kinetic energy? Therefore, work done is equal to F S cos 180 degree. Isn't it? So how much is this? And force is mass into acceleration, negative, S minus 1. What is acceleration? Negative, right? So basically you will have m MAS. This is what you get. If force is, what is the angle between force and displacement? 180 degree. But what is force itself? Mass into retarding acceleration. So minus A. So minus and minus, this becomes plus. So this is MAS. So this much work is done in opposite direction. Now what is the displacement? What is the displacement? So S is equal to, what is the formula? B square minus U square, right? Upon 2A. Isn't it? But what is final velocity? 0. And U was V. Initial velocity is V. Okay? And this is divided by 2A is actually minus A. Right? When you substitute. So you can write down. Why? Since final velocity V is 0, initial velocity U is V, and A is basically minus A, retardation. So when you substitute in this, all this, you get this. S is equal to, now this is minus and minus cancel, you will get V square by. So substitute here. So this is 1, and this is 2. On 1 and 2. What do you get? W is equal to MA into V square by. So what do you get? Half MV square. So this is work done, which is nothing but kinetic energy. Everyone got it? So in your textbook it is little confusing, so write down these steps with right. Right, but
Sir, from where A came?
from force. What did we say? How do you calculate kinetic energy? It is equal to the work done in stopping a moving body. So to stop a moving body, you have to apply force in opposite direction. So that force is generating retardation. So it's a negative force. It's minus M into minus A. F is
B square.
how V square. V is the final in the equation of motion. What is the third equation of motion? V square is equal to U square plus 2AS. So U goes to other side, V square minus A, and 2AS net, S is kept there, U will come in denominator.
So this is not there.
Huh? No, this is what we know. This we already know from 9. This is from our knowledge of equation of motion. By third equation of motion. By third equation of motion. So for any motion, we can use this too. So, but in this case, since V is 0 here, what is V? Finally, the body is stopped. So final velocity is 0. And initial velocity, body was moving with V. So here the symbols are changing. Final is 0 squared. 0 hi ho jayega. And U becomes V. Then this minus minus cancel. Okay. In your book, you will not directly you're getting the result, but these signs, how the signs are absorbed. So better you write it. Right? Next is work energy theorem. Have you written it down? Can you erase the first one? Now you have a body which is moving with some velocity u. I'll explain. So the kinetic energy of any body of mass m moving with velocity v is half mv squared. Next we are deriving expression for work energy theorem, which is given as W is equal to final K final minus K initial. That is W is equal to, what is K final? Half mv square and half mu square. So initial kinetic energy will be half mv square. What's a very close? Let me know once you are done writing here. Writing here. Okay. Change in value. Shall I explain work energy theorem? Now look here. So we have a body of mass m, right, which was initially moving with velocity u. Now a force is applied in the same direction, so it will gain acceleration.
Yes.
So therefore its new speed will be v. Okay, because it accelerated in this direction. Okay, so we want to find out the relation between the work done in displacing a moving body. So far we had a stationary body, we moved it. Now we have a moving body, we worked on it, so its speed increased. So work done on the body is whatever is the force applied over this displacement s. So we kept pushing this body till this displacement. So what is the work done? F into s.
Yes.
And of course cos 0. I'm now not writing. Okay, cos 0 is 1. So what is F? MA. And what is S? I traveled this distance, initial speed v, final speed v. So this will be v square minus u square upon 2a. Correct? Okay. So now this is cancelled. What do we get? W is equal to m multiply inside half mv square minus half m u square. So we got the formula. So therefore, what is the relation between work done on a moving body? This is equal to K final minus K initial. What is half mv square? This is the final velocity. This is the final kinetic energy. Half mv square. And half mv square is the initial kinetic energy. Because kinetic energy is half product of mass times square of velocity. Oh yeah, this is work energy here. Got it? So in English, work done is equal to gain in kinetic energy. Okay, which is the difference. What is K final minus K initial? Whatever kinetic energy is increased. So work done on a moving body shows up as a increase in its kinetic energy. Got it? Next. So how many types of kinetic energies are there? Types of kinetic. क्योंकि फोर्स इधर है ना और डिस्प्लेसमेंट इधर है, फोर्स किधर लग रहा है, इस तरफ लग रहा है, तो ये क्या है, 180 डिग्री डिस्प्लेसमेंट और फोर्स।
Then 180 cos square is 1.
-1 cos 180 is -1 बताया पहले 2 हफ्ते पहले, ठीक है। So there are kinetic energy कितने टाइप का हो सकता है? अगर बॉडी स्ट्रेट जा रही है तो इट विल हैव ट्रांसलेशनल काइनेटिक एनर्जी, अगर बॉडी घूम रही है तो इट विल हैव रोटेशनल काइनेटिक एनर्जी, बॉडी वाइब्रेट हो रही है तीन ही टाइप का मोशन है, ट्रांसलेशनल, रोटेशनल और सर्कुलर और वाइब्रेशन, ठीक है। तो मोशन जितने टाइप का है उतने टाइप की काइनेटिक है। सो ये ट्रांसलेशनल काइनेटिक एनर्जी। दूसरा क्या है? रोटेशनल काइनेटिक एनर्जी। तीसरा क्या है? वाइब्रेशनल काइनेटिक एनर्जी, ठीक है। एग्जांपल ऑफ ट्रांसलेशनल काइनेटिक एनर्जी, any moving car, train, aeroplane, any body which is undergoing straight line motion will have translational. So any body moving in a straight line will have translational kinetic. And for this, any body moving around its axis or revolving, okay? So any body spinning about its axis, like the electric fan or the wheel of the car. So wheel of the car will have both. It's spinning, so as rotational, plus it is moving ahead. So it has both the rotational as well as translational kinetic. I mean, car doesn't roll at one place, right? It rolls and moves ahead. So the wheel has both rotational as well as translational kinetic. What about vibration? Any vibrating body? Any vibrating body, like clock, pendulum of the clock, like clock pendulum. Atomic vibration, like in case of solids, atoms are tightly packed, but each atom is vibrating, it is never still. So they have vibrational energy. Yeah, repulsive, attractive, both. They are held together, so they are attractive. But they are attractive only at a distance. When they come close, then they are repelled. So the nature of forces will learn in 11th standard. ठीक है? और atoms in solid. Now in gas, what happens? Gas. Say monoatomic, diatomic, polyatomic gases, right? What is monoatomic gas? Helium, argon, they are just single type of atom. when you have two types of atoms like carbon dioxide, it's diatomic. When you have multiple atoms, then it is polyatomic. Like HCl and all, these are polyatomic. Okay? Not just two. Is there any other? H2S, hydrogen sulfide. So there are like different types of gases. Monoatomic, diatomic, and so diatomic is okay. Oxygen. So it has two atoms. That is diatomic. Single atom is monoatomic, like helium or organ. Then you have polyatomic, like HCl. These are multiple atoms. Okay? Or CO2. Okay. So in single type of atom, what do you have? Translational kinetic energy or rotational. If it is moving like this and also rotating. Okay? So in polyatomic you have all translational, rotational as well as vibrational. So these two atoms, let us say you have diatomic atoms. So they are going like this and they are going ahead also. All energies are there. So if they are vibrating, vibrational. While vibrating, they are rotating. And if they are doing this, like a DNA structure also going up, so it has all translational. Got it? So gas is very complicated motion. Most simplified is metal or solid because atoms are held together. Is it clear? Yeah. Take it easy. Huh? Okay, now types of kinetic energy understood. Next is potential energy. What is the symbol of potential energy? U, right? So there are two types of potential energy. First, what is potential energy? It is the energy associated by a body by virtue of its change of position or configuration. दोनों में से कुछ भी चेंज होगा. कॉन्फ़िगरेशन एज इन शेप. पोटेंशियल एनर्जी दो टाइप से हो सकता है. इफ यू चेंज द पोजीशन ऑफ द बॉडी और चेंज द शेप ऑफ द बॉडी. अब देखो, अब जैसे ये डस्टर है, ठीक है, if it is lying on the ground, so it has no energy, right? Now if you lift it up, okay, now it has energy. How to see that? Now imagine it is a hammer. So hammer is raised, it now has energy. Now if the hammer is dropped, yes, so if there is any needle, okay, when the hammer hits the needle enters into wood. So hammer does work on needle. So if you leave it, if it falls on anything, it will do work on that. Okay? So what has happened? When you worked on it in lifting, it gained potential energy, which is equal to mgh. Isn't it? What is the work done in lifting a body? mgh. Right? Now when you leave it, it is converted into kinetic energy because here it had mgh, but now when it is hitting the ground, it is hitting it with some velocity, so it will have kinetic energy. Okay? So therefore, so there are two types of potential energy. Two types, just like kinetic energy. Two types of potential energy. One is gravitational potential energy. right? So how is it given? So gravitational potential energy is equal to work done in lifting a body. In lifting a body to some height against the force of gravity. Okay? So suppose you had any body which is at ground, its mass is m. Now what you are doing? You are lifting it up. That's some height h. They are applying some force on it. How much this force should be? At least equal to its weight. When you are lifting a body, you are basically overcoming its weight, which is the force downward on it, right? So force is up, displacement is up. Now you took the body to this position. So whatever work you did in the body, that will be stored as its potential energy, right? So therefore, U is equal to F into H. And again, theta is 0, so cos 0 is 1. So what is F? At least mg H. So this is the expression of potential energy. So gravitational potential energy of any body is given as mgh. Whatever work you do in lifting, that is the potential. Okay. Now next is elastic potential energy. So how this energy came? By change of position. So initially the position was, let us say, A. Position A. Now this is position B. Right? So when the height is more, the potential energy will be more. So what is the potential energy at bottom? 0. Because H is 0. Okay? Potential energy increases with height. So which type of potential energy it is? Gravitational. Okay? Why do we call it gravitational? Because we are lifting the body against the force of gravity. Okay? Up देखो configuration. Next is called elastic potential energy. So where does it lie? Spring, right? So it is found in spring or stretched rubber band. Compressed or stretched rubber band. Compressed or stretched spring. Compressed or stretched spring. ठीक है, rubber band. ठीक है, so देखो, suppose you have a relaxed spring. Let's say this is something. And you have kept some ball on it. So what is it? Relaxed spring. So there is no energy in relaxed spring. Now you compressed it. How did you compress? By applying some force. And the ball is kept on top of it. Okay? You compressed it. now this has potential energy. Why? Because when you compressed it, when you applied the force in this direction, spring is exerting force in opposite direction. The moment you remove the finger, it will try to regain its relaxed position. That is its equilibrium position. Now you disturb the equilibrium. So it will try to search equilibrium position whenever the first chance is found. Like removing the finger. Then what will happen? You will see that it will throw the ball up. Again it will, and the ball will move up with some velocity. So whatever was the spring or elastic potential energy, right, that will show up as kinetic energy of the ball. Okay? Got it? So what you have seen here is conversion. So when a body is falling freely, then potential energy is converted into kinetic energy. Here also, when the elastic potential energy is released, it gets converted into kinetic energy. This is the principle on which gun, revolver works, right? So it will shoot. So when you pull the trigger, the elastic potential energy is stored. When you release the trigger, it will hit the bullet and bullet will move forward. Okay? Got it? So where is elastic potential energy found? So what is changed? The configuration is changing. The shape has changed. Right? It is compressed or it is elongated. Spring will have elastic potential energy in both cases. If you stretch it like this, like in case of bow and arrow. So when you stretch the cord of the bow, then it has elastic potential energy. When you release it, then the bow moves with the kinetic energy. So that potential energy in the spring is converted into kinetic energy of the arrow. Got it? देखो और एक केस कैसा हो सकता है? Let us say you have a this is the bow and arrow. In this situation, there is no kinetic energy because the elastic is relaxed. Now when you stretch it, right, then what will happen? The bow comes here. When you release it, that time the arrow will shoot. So in this position, stretched rubber band, the shape is changed. Shape is changed, right? Now it has elastic potential.
The same is also slingshot as well. Same is also slingshot.
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 Slingshot, yeah. Because it has a rubber band, right? So same thing. So wherever the shape is changed, then and it is dangerous. Because if it regains its shape, it should happen with the knowledge. Without knowledge, you'll get hit. Like if you hold the balloon, you'll get a tight slap. Okay? So like that. So elastic potential energy is in all the places wherever the change of configuration or shape is taking place. ठीक है, समझ आ गया? And we have calculated the expression for gravitational potential energy. Okay. So these are all the types of energy. Then this also demonstrates conversion of potential energy into kinetic energy. This diagram shows conversion of potential energy into kinetic energy. This diagram. So here, this TE to AE. Here also. Here you have potential energy. When you leave it, then it will go ahead. Right? Right, no? Therefore, so I'll draw it in different color. This is the situation of bow when it is pulled. And this is the original situation. When it was just here. Got it?
Afterwards, when it is full line, it will have potential energy when it is in this
Red has potential energy. Where is the potential energy? In the
string.
string. Now when you release it, that potential energy is converted into kinetic energy of the bow. So bow will have now kinetic energy when released.
After the blow falls down, then it will have kinetic.
It will have nothing. It has no motion, nor does it have any height. It is on the ground, right? Okay, so gone. Is it clear? Now there are so many forms of energy. Main is only 7. So we'll just have a quick discussion on all of them. So there is a difference between potential and kinetic. Just read through this table. See if you have any difficulty. Ask me. So in this chapter, only this part is important. Then there is conversion of one form of energy to other form, that we'll see. We have already seen the conversion from potential to kinetic. Okay? And this is in case of mechanical energy. Now different forms of energy can also be. Light can be converted into heat. Heat can be converted into mechanical. We'll see that.
The light is just solar energy.
Light is solar energy. Solar energy is the, how, in what form is it available?
Like
Radiation.
radiation.
It comes in the form of radiation. So I'm erasing this part. Is it okay?
Yes, sir.
Second column.
No, sir. Just
So let me list down all the. So you have different forms of energy. There are some 12 forms given. So under light you will have light, then solar, these are related. Okay. Then you have heat, geothermal is also heat. I'll explain. Then you have mechanical, electrical energy, magnetic, mechanical is also heat energy. So wherever there is motion, okay, that is, then you have chemical, clear. Stop. Then you have hydro. So you have 12 different forms of energy, but now I have converted them into basic forms. Right? See, in your book, different forms of energy are mentioned. I have grouped it in basic forms. So light and solar are together. Okay? Heat and geothermal. These are heat energy. Let's understand. Mechanical, wind, hydro together. Motion is involved everywhere. Okay? Then electrical and magnetic. Magnetic energy comes from electrical. Right? Chemical. Then you have nuclear and sound. So let us understand. So light is basically the sunlight, and the energy of light is called solar radiation. So light enables us to visualize things. It makes us see things, makes things visible to us. Light energy helps us see things, right? So it makes things visible to us. What about solar? It can then give you heat. Solar can give you heat. Solar water heater on the rooftop. It gives you heat. Right? You have geothermal energy. So with that heat you can produce steam and then you can produce electricity. Or you can use that steam, like earlier you used to have steam engine.
Yes.
So that you can use to get mechanical. That is how heat to mechanical. Right? What is geothermal? देखो होता क्या है?
The energy stored below the Earth's crust.
So in the Earth's crust, there are a lot of nuclear radiation taking place. So in the nuclear reaction, what happens? A lot of heat is produced. Right? Nuclear energy means a bigger nucleus breaks into two smaller nucleus. Okay? So mass of this nucleus is capital M. This is M1, this is M2. The combined mass of these two is actually less than capital M. So you'll get a mass difference, delta M. Whenever you get a daughter nucleus after a nuclear reaction, this is a fission type of reaction. When a bigger nucleus breaks into two parts. Okay? So there is a mass difference. That mass difference appears as energy as per Einstein's equation. This mass difference appears as heat energy. Heat energy. So every nuclear reaction produces tremendous amount of heat energy. So this reaction fission could be natural also, like it is taking place in Earth's crust, or it can be caused in laboratory, like in BRC. Okay, so in BRC what we do? We have a big uranium nucleus, we break it into two parts. So whenever we break it into two parts, lot of heat is released. Plus it produces, how do we break a uranium nucleus? By hitting it with a neutron. So when it breaks into two smaller nuclei, three more neutrons are also produced. Those three neutrons then collide with remaining nuclear fuel, that is uranium. And then each three neutrons are causing three different nuclear reactions. So from 1 cause 3, then 9, then 27. So a chain reaction. That is atom bomb. So if we don't control this reaction, it will result into atom bomb. So much destructive energy, like so much heat energy, that it can annihilate anything which is coming into its reach. Okay? So therefore in BRC what do? After one reaction, we don't allow three reactions to happen. The remaining two neutrons, we will just bring it away. And the next, after first reaction, the next reaction is also single. So it is called controlled reaction. Then we have constant availability of electrical power. But if we let it loose, chain reaction, then it will be explosive, atomic explosion. That's what is nuclear energy. Okay. There is another form of nuclear energy which is called fusion. So fusion is opposite. Here two small nuclei are
Combination.
two small nuclei are combined to give you a bigger nuclei. In this case, the mass of the bigger nuclei is less than sum of these two. So in this case, delta M is always the product nucleus mass is less than the parent nucleus. So in this case, delta M is M1 plus M2 minus M. Again, this difference of mass appears as energy. Okay, and this EmC square, E is equal to delta MC square, is much bigger as compared to fission energy. So this is how energy production takes place in sun. Two hydrogen nucleus combine to produce a helium nucleus. Okay, but the problem is fusion takes place at very high temperature. Fusion takes place at very high temperature. Like how much? At least 10 raised to 6 K or 5 K, minimum 10 raised to 5 to 6. One to 10 lakh Kelvin. And you know where is this temperature found? In the core of the sun. On the surface it is 6000 Kelvin. Okay. And at this temperature, no substance can hold itself, it will melt. That is why we don't have any fusion based nuclear reactor. All the nuclear reactor we have are fission based. Again, still research is going on as to how do we cause fusion. So if we succeed in this, then we'll have unlimited source of energy. Just have one fusion based reactor, the whole world requirement is met. Because then we can have sun on planet Earth. Right? So if you have sun on planet Earth will cease to exist. So we have to have a controlled environment. Anyway, let's
So the remaining gets in heat energy.
Every energy, the useful, see, like when
In
you
between means that energy when it is combined.
this is heat energy only. Whatever mass. This is as per Einstein's formula.
Yes.
Mass energy relation. So basically, what happens is in every nuclear reaction, whether it is fission or fusion type, what we obtain is heat. Then we use that heat to produce steam by heating water. That high pressure steam is capable of rotating the turbine.
Yes.
And then that turbine can be connected to generators, so that will produce electricity. So we don't use the heat energy produced by nuclear reaction. We convert that into electricity because that is the most conveniently used form of energy we have today. We know how to distribute electrical energy, how to use it. All the appliances that we have today work on electricity. And it is only possible that one form of the energy can be converted into other. Otherwise, directly nuclear energy of no use. Right? What is the other destructive use? As a weapon. Right? So that now sound is basically used to communicate. Right? How it is produced? Vibration of the vocal cord. Or any vibrating body produces sound energy. Okay? Chemical, anything which you burn, wood, when you burn, it produces heat. So basically, two most used form of energies are electricity and heat and light, these three. Isn't it? Sound to communicate. In fact, all seven. Right? And then indirectly, all this. Clear? Clear or no?
Yes.
So chemical energy is produced when fuels are burned. This fuel could be in the form of petrol, diesel, wood, coal, anything when you burn, it is an exothermic reaction. Isn't it? What are we? What kind of energy is stored in us? Calories.
Yes.
What unit is calorie?
Joule.
Heat. Calorie is the unit of heat. Right?
Density.
So inside us, so how do we get calorie? We eat food. So food is chemical energy. When we eat, we produce heat. So there is an exothermic reaction. If we don't eat, can we survive for some time? No. Can we not survive without eating? By breathing. We will die only for breathing is stopped. As long as we are breathing, we are getting energy.
But after 3 days we can do.
10 days.
But you live for 3 days, that is it not big enough? There are certain creatures who live for like 2 minutes. Mosquitoes and
8 days. But 8 or 10 days
10
we
days.
can survive without.
5 days.
that's what I'm saying. So what for all those 8-10 days, are you breathing or no?
Yes.
So respiration is also an exothermic reaction. That oxygen that you are inhaling through your blood, right?
Yes.
It converts it into glucose and you get heat. So that is also exothermic reaction. So ultimately, any form of energy, you end up converting it either into heat or electricity or light so that you can use it. Okay? Now, is it clear? So electricity to magnet, every electric bell, we have seen last year how the bell rings, right? So we have an electromagnet. You make, so pass electricity and what you get is an electromagnet. So these are together. Wind energy. What is wind energy? So when the wind is blowing, it has kinetic energy. So that can be used to rotate a
Wait.
wind mill. And that mill can be used either to rotate a generator. And then we can get from wind energy, we can get electricity. Similarly, hydro, moving water.
Kinetic energy of the water is completely electric.
Yes, so we have a dam which is holding the water, so it has potential. Now, when you release that stored water, then it has kinetic energy. Then it hits the
Turbine.
turbine.
Turbine when you use the kinetic energy, yes.
Yes, so the kinetic energy of the moving water is converted into rotational energy of the turbine. That rotational energy rotates the generator that produces electricity. So everything is linked. And you can have mechanical energy produced. So if you have electric train, right? Electricity is fed into train, now you are moving train. Okay? So everything can be converted into one energy. Got it? So wind energy to mechanical energy. Wind energy to mechanical energy. Wind. So you have a boat. Earlier you had big curtains, right? So when the wind, so you just guide the curtain in the direction of wind. Okay, or you can alter it to navigate in a particular direction. So many examples you can think of. So ultimately you will see that there are only these 7 categories. Now geothermal, I was explaining. What is geothermal? So there are some natural nuclear reaction taking place in Earth's crust. So nuclear reaction, that means it will produce heat. So when the groundwater comes in contact with that heat produced by nuclear reaction taking place inside Earth, that groundwater is converted into steam. Now steam is very useful. We can run a what engine? Steam engine, right? Likewise, we can use the steam to rotate a turbine because at the pressure cooker, so much pressure is there. We have seen it, right? So that steam is pulled out by drilling pipes. Okay, so there are certain locations on Earth, like in US or New Zealand somewhere. When you insert pipe into the steam repository, those high pressure steam can be brought out. And then it can be guided to turbine to rotate them to produce electricity. So that geothermal, Earth's thermal energy can be used to produce electricity. And heat can be produced by many methods, through light or by burning fuel. So chemical energy end up converting into heat. Then we use heat to cook food, etc. Okay? Heat and light. Okay? So now when you read all this, you will be able to understand. Which topic? Different forms of energy. Then you have conversion of one form of energy to other form. Now this is very important. So how do you do conversion? You need appliance or device. So one conversion we have seen, potential to kinetic. Have you seen potential to kinetic conversion? Now, then there are some other conversions. Other conversion amongst these. So what kind of questions are asked? Look at the diagram. There is a diagram given in your book to explain conversion of one form of energy to other. To other form. Now look at this diagram. There are some 17 different types of conversion given, but don't get confused. It is different combinations of these. Okay? So first and foremost, you remember this diagram. This diagram. Okay? So how do you convert? By using a suitable device. Suitable device or appliance. Okay. So if I now ask you, look at the diagram, first one. How will you convert mechanical energy into electrical energy? By using a dynamo. See, left to right. How can you convert? By using a dynamo. Dynamo is generator. Okay. So first is mechanical to electrical. Question comes, how will you convert mechanical energy to electrical energy? You will say by using a dynamo. Now see the reverse arrow, right to left. How will you convert electrical energy to mechanical energy? By using a motor. So fan, you switch on the current, that means you pass electricity, then you get motion, like mechanical energy. Okay. How to convert electrical energy to heat energy? Electric iron. See the diagram. See the diagram. Figure 2.11. Okay?
By electric fire.
So, and how to convert heat energy to electrical energy? By using thermocouple.
Yes.
What is thermocouple now? So there are many ways in which electricity can be produced. One is by generator. Other is by rubbing hands. Further is by chemical energy to electric energy, like in cell. You separate charge. I've shown you in 9th standard how a cell produces electrical energy. There is a reaction between the electrolyte and electrodes. Then one of the electrode becomes positively charged, another electrode becomes equally negative charged. So there is a potential difference maintained due to chemical reaction. So the third way we saw is producing electricity by chemical reaction, right? So chemical reaction, rubbing and generator. Okay. There is one more way in which you can produce electricity, which is called thermocouple. In thermocouple, what you have in thermocouple is you have two different types of metals. Let us say one is copper, the other one is iron, let us say. Okay. Then this is iron and then this is, say, copper. And this is your circuit. Let's say this is the galvanometer kept. Now this is metallic junctions, copper and iron junction. This is also copper and iron junction. One of the junction you keep it at higher temperature and one you keep it at lower temperature. Let us say this is at cold junction. One is cold junction. This is hot junction. So the difference in temperature is heat. Heat flows from higher temperature to lower temperature. So there is difference in temperature. Whenever you have difference in temperature, then you will see a current flows. So there are so many ways in which electricity could be generated. One of them is thermocouple method. So you have different metallic junction kept at different temperatures will produce electricity. So as long you can maintain one junction at higher temperature with respect to the other, you will have continuous flow of electricity. So is this energy coming from somewhere? Yes, we are burning or some heater is kept here. So we are converting heat energy into electrical energy. The moment you both the junction achieve same temperature, current will stop. ठीक है? है कि नहीं? हमें खुद से तो ये hot and cold पे नहीं होगा ना, करना पड़ेगा, burn करना पड़ेगा, तो उसमें क्या energy use हो रही है? Heat energy. So heat energy is converted into electrical energy. आगे बात सर? Explain करो क्या होता है? अरे समझ गया था ना? You are not listening. So second diagram complete, right? So ठीक है, सिर्फ इतना बोल देना. So what is second? Electricity to electrical energy to heat energy, electric iron. ये तो बहुत obvious है, हर घर में करते हैं. दूसरा heat energy to electrical energy using thermocouple, लिख देना है. Okay? Third, electric energy to sound energy. Speaker, device use करना पड़ेगा by using a suitable device. तो electric energy में current pass किया तो हमको क्या मिलता है? बड़ा sound मिलता है. ठीक है. Then sound energy to electrical energy. Microphone. When we speak in a microphone, then recording takes place.
Yes.
Recorded, हमारा voice recorder record हो गया. मतलब now it is in the form of electrical energy, magnetic or electrical whatever. Okay. Then we can replay that, and again it is electrical to sound. Okay. So ये सब का knowledge होना चाहिए. तो question ऐसे ही आता है. How will you convert sound energy into electrical energy? क्या आंसर दोगे? हाँ? Microphone. Sound to electrical is microphone. ठीक है? Electrical to sound is speaker. Okay. चलो आगे का पढ़ो. Electrical energy to chemical energy. Charging a battery. When you charge a battery, what are you doing? You are strengthening the electrolyte. ठीक है? And when you are using a battery, you are converting chemical energy into electrical energy.
As it is in the secondary battery.
Like in case of secondary, तो उसमें you can do both, charge and discharge. Okay. ठीक है? Then chemical to light energy. So whenever you are burning anything, like wood, you will produce fire, so you will produce light as well as heat. Or if it is candle, when candle is burnt, what are you doing? Wax is burnt and it is getting converted into light.
So also heat is also very released.
Yes, of course. Whenever there is light, there will be heat, right? And light to chemical, photosynthesis. All the plant, what do? They absorb sunlight, and then what do they produce? Chemical energy in them. Okay? So that is photosynthesis. Then electrical to light energy again by using electric bulb, right? And light to electrical energy is photocell, the solar cell, right? So light falls on it, then it converts it into electrical energy. Like street lights, you have seen street light with panels like
Yes,
this.
sir.
So they have seen so many solar panels connected. All right. Now one thing you have to keep in mind is, whenever you are converting one energy to other, one from one form to other form, there is not 100% conversion of energy. Some of the energy is wasted in the atmosphere. That is so. Yeah. So that is efficiency, 40%, right? Out of the 100% consumption, only 40% is producing useful work. Because 100% conversion never takes place. If it was 100%, then the efficiency will be 100%. Like when I am teaching you 100%, you are getting how much? 10-20%. So 80% is gone because
So 80% came 10% last.
is it? That's a very good efficiency. That's a very good efficiency.
For me, I said.
Huh?
For me,
Okay. Because why? Body has a limitation. It cannot be like when you came in morning, you had a lot of energy.
yes, sir.
Now energy is dipping. The efficiency is going down. It's like that. So you have to get recharged, eat, sleep, play some games on mobile. Not football. Okay. So what I'm saying is this energy which you were spending, which did not convert into useful form, it got wasted in the form of heat. So that energy which is now in non-useful form is called degraded form of it. So there is always, like if you have a machine, right? Let's say a machine is supposed to take you, automobile for example. So all the fuel which is burned is not translated into linear motion. You have smoke, you have heat of the engine. So all the automobile parts are rubbing against each other. So heat is produced. That is a wasted energy. So if it was not gone into heating the system, it would have taken us few kilometers more. Got it? So all that energy which is converted into wasted form is called degraded energy. Okay. And in no conversion takes place with 100% efficiency, in short. Why? Because frictional forces are always available. Right? When I am running outside, there will be wind. So there is a wind will cause drag. So I have to work against that. So when wind is touching and going like this, the atmosphere through which I am moving will become hot. So my energy is gone in overcoming wind. Okay? These are called dissipative or dissipation of energy or degraded form of energy. So whatever. Alright. So with this we are done with unit B of this chapter. Now only one part is remaining, which is conservation of energy. I think some of it we did in the last class, right?
So that was a doubt for Sandy's.
Doubt for? She had only asked. Gargi only had asked. So now we have 15 minutes and we can do that conversion of conservation of energy. And in the next class, then we'll take up the remaining. Okay? Everybody has become like zombie. Yes, no, yes, no, as a joke. Yes, yes.
Also, we can do some speed.
Americans will do with fresh mind. Let me do the work, so you listen. In this chapter now, what we are going to do next is important. Conservation of energy, right? So anybody remembers what is conservation of energy?
Conversion of energy from one form to
No, that is conversion. We are saying conservation. Last year also we studied. Okay, so what is conservation of energy? So this law holds when there is no dissipation, no loss of energy. So there is no friction. Okay, only then this holds, right? What is conservation of energy? Law of, this is unit C now. Law of conservation of energy. This we have studied last year also, right? Which means energy cannot be created nor it can be destroyed. Right? It can only be changed.
changes from one form to another.
It can only be changed. Only be changed from. So this is a wasted energy, right? He was making sound, dropped it, right? Only we change from one form to another form. So energy of the universe is always constant. Let us say universe has 100% energy. Universe. Let universe has 100% energy. So where is it divided? Huh? Where is the energy of universe divided? 1, 2,
At the
3,
center.
4, 5, 6, 7. In these 7 different forms of energy. How is the universe energy divided? In these 7 different forms. So whenever the conversion is taking place, right, it happens among these 7 forms. It will totally remain 100% by capturing useful as well as degraded. Although degraded is not useful to us, but it is still there in the universe, right? It did not leave the universe. Got it? Sure. So we have to prove this law of conservation of energy for 2 cases, for a freely falling body and for pendulum, right? So उसको कैसे लिखेंगे? Verification of conservation of energy in case of freely falling object. What are we doing? What are we doing? Verification of conservation of energy in case of freely falling object. And what you have to assume? Assuming. What is the assumption? Assuming there is no loss due to frictional force. Just friction. There is no loss due to friction. So when the ball
This
is
can only occur only in vacuum, right?
yes, only in vacuum. और by assuming, assume करो कि नहीं है यार, तो मतलब vacuum. Yes. अब देखो. So let's say you have this ground. Let's call the ground position as so freely falling. So first the body has to be at top. So at top we are calling the position as A. Somewhere in between we are calling the position as B. And the ground we are calling the position as C. Okay? What are the 3 positions? At the top, in between, and at the ground. Let us say the top position is at height h. Okay? This is the height h. So what is h? AC. Okay? So at AC, what was the velocity at the top?
Velocity.
0. So now let's write down what is its energy in different form. And then E, which is equal to U plus K. Okay? At various positions, we'll write down its energy. Since V is 0, what will be its kinetic energy?
0.
Because kinetic energy is half mc square. U is equal to what? mgh. ठीक है. तो यहाँ पे क्या आएगा? What is? This will be maximum mgh. Because height is maximum. What about kinetic energy? 0. What is total?
mgh.
Now let us say now the ball falls from here to here, say by x. Kinetic energy wasted into heat and sound. Now how much at position B? What is the height of the ball? Pay attention now. What is the height of the ball at position B? H minus. So what is the potential energy now? mg h. What is the height? mg h minus x. And what is the kinetic energy? What is the speed here? Let us say the speed of the ball here is VB. Okay? So what will be kinetic energy? Half m VB square. But how much will be that VB equal to? VB will be equal to how much? Yes, you have to use that formula. V square is equal to, VB square is equal to U square, which means 0 plus 2gx. What is the displacement? X. So this will be equal to U square is 0, U square 2g. So it will be half m. This is equal to half m. ये तो रहेगा ही. Then 2gx, because that is the whole of VB square. Okay? So what is the energy then? mgx, and mgh minus mgx plus mgx will be again mgh. Have you understood this step? How did we get VB square? Explain. How did we get VB square is equal to 2gx? So we have V square is equal to U square plus 2AS, right?
Yes.
So what is the U in this case? 0. And V over here is VB, so we are calling it VB square. A is downward, so G is it's going downward. So what is A? G. How much is the displacement in the downward direction? X. For position B, from top position is AB, which is X. That's how we get 2gx. So what is 2gx? VB square is 2gx. Okay, that's how. And when we add these two, when we split, so this will be mgh minus mgx. And when we add these two, so this is you are getting mgx. Okay, this is the kinetic energy at B. So kinetic energy at B is this. So when you add these two, you get mgh. Clear? Now at C position, what do you get at C? What do you get at C? What is potential energy? 0. Because H is 0. H here is 0. That's potential energy. What about K? So it will be half mvc square, and it will be half m 2gh now. X is equal to h now. Correct? So when you cut it, so 0 plus mgh, again you are getting mgh. So throughout the free fall, what is the energy of the ball? Total energy? mgh. Total mechanical energy is constant. That is conservation. Because we assumed it is not losing any energy due to friction. So its entire energy is mgh throughout the ball. Okay? Pendulum you want me to do again?
No.
Huh? Pendulum का भी करना है ना? Verification of conservation of energy in case of pendulum.
Yes, sir.
कर दें? चलो उसमें तो कुछ है ही नहीं.
Sir,
You know, right?
Yes, we know. It is in the down process.
So the question is, verify law of conservation of energy in case of swinging pendulum. So how do we verify? This is the mean position. Let's call the mean position as A. Now it is displaced at one side, say position B, and then released. So it will undergo vibrational motion around both sides of the mean position, like this. Okay. So now tell me what is the nature of energy at B? So imagine if you take this difference. So this is the height of B, vertical height of B with respect to positioning.
Yes, sir.
So whenever there is height, so it will gain potential energy. So what will be gained in potential energy at B? UB is mgh. At extreme position is like top position. What is the velocity? 0, because it is moving, slowing down because gravity is trying to pull it back. So at extreme position, its velocity is 0. That time kinetic energy at B is 0. So what is the total energy at B? Okay. Now this full energy is now converted into kinetic energy. Here also you see the full potential energy is now converted into mgh. So kinetic is converted into potential. Potential is converted into kinetic totally, right? So that's what is happening here. So here the height is 0. So what is potential energy at A? 0. Therefore, what is kinetic energy at A? It must be mgh. Okay, the same potential energy is converted. If potential energy is 0 and there is no frictional losses during the oscillation of a pendulum, what is the assumption? No frictional losses.
No friction loss by air.
No friction loss by air because only air. So it is happening in vacuum effect. Right. So what is the total energy E at A? mgh. Okay. What about energy at C? Again, it is same case as B. So U at C will be again mgh because it will rise the same height as it was at B. So what is the height difference? This is h. So what is kinetic energy at C? 0 because extreme positions. So what is the total energy at C? So we saw in case of a freely falling body as well as in case of swinging pendulum, assuming no friction loss, total energy at all positions is same. Extreme position it has only potential energy, right? Mid position it has only kinetic, and in between it will have both potential and kinetic. U plus K. Here also. So here also at extreme position it has only one form of energy. Top is potential, ground is kinetic, and in between it has both potential as well as kinetic. So the amount of potential energy which is reduced appears as kinetic. What is minus mgx here is plus mgx over there. Okay. So what is the thing to understand here? During change of energy, it is the potential energy which gets converted into kinetic energy. And how the body gets potential energy? Some external agency worked on the body. Okay? So that's it. So this is the demonstration of conservation of. All right. See you later.
आपको पता चल गया है कौन बोलती होती
आई तो मैम नहीं किया मैम ने एक्शन कुछ नहीं लिया प्राइमरी बॉल है ना बॉल हां राइट तो रिटर्न मैम रिटर्न
इसके नेक्स्ट टाइम तो हुआ है इसके तो झूठ जाएगा ये तो ऐसे लगा
आज ये बात मुझे 445 विशिष्ट के साथ ही आशीष को बोल दो तू भी आ जा
तू भी तो चाहिए गाड़ी
अरे